Hello, everyone, and welcome to the Future Space. I'm your host, Daniel Fox. Our guest today is Brian Greene. Brian is professor of physics and mathematics, renowned for his groundbreaking discoveries in superstring theory, including the co-discovery of mirror symmetry and spatial topology change. He is known to the public through his books, The Elegant Universe, The Fabric of the Cosmos, and The Hidden Reality. The Washington Post called him the single best explainer of abstruse concepts in the world today. Professor Greene hosted 2 Peabody and Emmy Award-winning Nova miniseries based on his books and is a frequent television guest, joining Stephen Colbert several times and playing himself in an episode of The Big Bang Theory. He has also had cameo roles in a number of Hollywood films, including Frequency, Maze, and The Last Mimzy. With producer Tracy, Greene co-founded the World Science Festival and is the director of Columbia's University Center for Theoretical Physics. Brian, welcome to the Future Space.
Thank you so much. Good to see you, Daniel.
What would be your 3 words that capture the essence of space?
Well, I come at space a little bit differently from space exploration. So I speak to the fundamental qualities of space. So I'd say dynamic, I would say expansive, and I would say emergent.
Emergent.
That's a much more recent idea, actually. If you want to get into that, I'm happy to describe what that
Yeah.
Yeah. So for ages, really millennia, anyone who thought about space viewed it as a pre-existing container within which the comings and goings of reality take place. No one until relatively recently imagined that there could, in principle, be a realm of reality in which space had not yet formed. It hadn't come into existence. And it's only if certain more basic ingredients arrange themselves in the right pattern that space itself is this environment that we're all familiar with. And so space emerges from something more foundational, something more fundamental that we're still trying to piece together what those basic ingredients, those like atoms of space and time might actually be. But that's the idea.
How far have you gone into the thinking or the concept of space since, I don't know, when you started to study it in school and where you are today? Can you look back and go and say, wow, we've covered so much ground? Or that was kind of predictable where we are today?
It's crazy if you think back. I mean, even in my own lifetime, when I was a kid, there was no real question about the number of dimensions of space, right? Space had, left, right, back, forth, and up, down, the 3 dimensions that we all know about, 3 dimensions of common experience. And then I remember when I was in college, caught a glimpse of this possibility that had been bubbling up since the early 1900s, it turns out, that maybe there might be more dimensions of space that we can't see with the naked eye, but might somehow be all around us. And I remember saying to myself, I've got to study this idea as a graduate student. And so when I went to graduate school, I was dead set on studying theories in which the number of dimensions of space might be larger. And miraculously, from a personal, individual standpoint, at exactly that moment, string theory really came of age in the early incarnation. And string theory requires extra dimensions of space. So all of a sudden, I was in this place of wanting to study extra dimensions. And now the world of physicists of the more theoretical orientation were really taking seriously this possibility that there might be more dimensions than meet the eye. And so, yeah, it's such a radical change, thinking back to where things were to the things that we're willing to consider today.
When you say dimension, are you talking about multi-universes in the likes of what Marvel movies have explored in so confusingly? Or you're talking about just different systems that we don't see, but are not necessarily duplication or related to ours?
Yes and no. It's somewhere in between those collections of descriptions. In many ways, it's more pedestrian than what you'd see in a Marvel film where, you go off into some other radically distinct realm that should be called a universe of its own. This like many worlds, many universe possibility. What I'm referring to now is a much simpler idea that I think is easy to grasp with an analogy. If I had a long garden hose that you look at from very far away, the garden hose will look like it has one dimension. It only really has length. Far away, you can't really see anything but the length. But if you're a little ant walking around on the garden hose, you realize, wait, I can walk along the length, but there's something else I can also do. I can walk around the garden hose. A circular dimension that you missed when you looked at the garden hose from far away. And so that's an example where dimensions can kind of come in two varieties. They can be big, obvious, easy to see, but they can also be curled up and tiny, much more difficult to detect. Now, the garden hose obviously is a object in our world, but we think our world itself could be like the garden hose. So you and I, everybody, we all know about the three dimensions of common experience. We navigate them freely in everyday life, right? We go that way, go this way, this way, up and down and so forth. Just three independent ways in which we can move. But the thought is, just like the garden hose has an additional curled up circular dimension, maybe our world has additional curled up dimensions all around us, but we can't see them because they're so tiny. If we were like hyper microscopic ants walking around in the micro world, we might be able to move along these extra dimensions. So in a way, they're very pedestrian. It's just like left and right. It's just smaller and hidden from our direct experience. Mathematically, though, we can study the possibility of these extra dimensions. And the wonderful thing is this idea of string theory requires extra dimensions. You can't get away from the idea. It's not like you just put it in because it's interesting. You're forced into considering it.
And if we take the water hose, and if you're an ant on top of it, you can walk around, but also there's the inside of the water hose that you can't see, that you would have to dig your way through so you can access it. And so there's always the different perspective wherever you are. There's always sides that you don't see. For me, it was often an observation that I had looking at the universe and how we think it's empty because we don't see anything. And I was playing the exercise that hypothetically you would ask anyone to come to Earth their first time arriving, and you ask them, what is it that you see? What do you think is the most important thing on this planet? They would describe the mountains, they would describe the ocean, they would describe everything that they see, not realizing that the air, which is invisible, is the most important thing that actually moves everything, all life on Earth. And we have to look at space in that same way. There's the visual aspect of it, but in reality, there's a lot that we don't see that could actually be in that same scale and that same importance as the air on Earth, right?
Oh, totally so. In fact, quantum physics pushes that idea one level further, because even a region of what you and I, with the naked eye, would say, no, that's a region of empty space. There's nothing in there, right? We don't see anything, and there's no matter, there's nothing. Quantum physics says that there's no such thing as a completely empty region, because quantum uncertainty requires that fields, like the electromagnetic field, which you would intuitively say must have a value of 0 if the region is empty, it says it's always fluctuating. It's always bubbling up and down. There's always some quantum jitter in an empty region of space. And moreover, we can measure the influence of those quantum jitters. There's a remarkable experiment that actually won the Nobel Prize called the Casimir effect. You take two metal plates and you put them next to each other, and they're neutral. There's no electric charge on them or anything. So they should just sit there in empty space. But in fact, what happens is they start to come together closer and closer and closer. And it's not a gravitational pull. There's not enough gravity to actually move these plates. Rather, the quantum jitters inside the plate differ from those outside the plate. There's an imbalance, and we can calculate this using mathematics. And that imbalance winds up pushing the plates mysteriously. There's nothing there. And yet they get closer and closer together. And so even empty space has activity. It has stuff going on that the naked eye, you can't see. And so those aliens, yeah, they don't see the air because it's invisible. But they also, like us, unless they've got super quantum mechanical sensors or something, right? They don't see what's going on in the region that I was just describing.
It would be hard to believe that the nature of the universe is different than the nature on Earth. We're part of the universe, and whatever has made Earth happen, the same dynamics are happening on a bigger scale. And nature is allergic to perfection. Like emptiness does not exist in nature. Even hurricanes are created just because air goes away in one place and then it sucks up the other one, because as soon as it creates an empty place, something else wants to move in. There's no reason to think that the universe would be different, that the sense of emptiness does not exist. It's just other particles or other things are moving in ways that we don't see.
I mean, I understand your intuition, and in many ways I share that intuition. You know, the laws of physics that we study here on Earth, the law of gravity, electricity, magnetism, the nuclear forces, which come in two varieties, the strong version, the weak version. We do expect that those forces are the same forces that are guiding everything out there in the wider universe. But, you know, that could be a parochial perspective. If you generalize too quickly from your experience, you can certainly miss things. For instance, life in our immediate environment would suggest that you are on the surface of planet Earth, but that misses life in the oceans. And so you could generalize too quickly and miss that quality. And so we do wonder, and our mathematical theories force us to consider the possibility that everything we know about the universe might just be kind of local bylaws that work in the small region that we call the universe, which of course is huge, but the universe might go on infinitely far. And so the piece that we know about the observable universe from that point of view would be a little tiny part of the infinite whole. I mean, no matter how big something is, if it's finite, it's tiny compared to an infinite expanse. And so if we were to go well beyond the bounds of what we can see, and we can see out pretty far into space, but if we go beyond the bounds of what we can see and much further still, maybe we find that the laws are different. Maybe we find that physics is different. Maybe we find that everything that we know about is just a misleading quality of environmental circumstances in the observable universe. You know, again, so maybe we would be doing the analog of missing whales and dolphins by virtue of extrapolating from our local experience.
Did you ever read the book, The Northern Lights? They have the subtle knife that can create an opening into different dimensions. That was interesting. Did you, talking about movies, have you seen Hail Mary?
I've not. My son was showing me the trailer just the other day, and it looks great. Have you seen it?
Yeah, it is a good story. They could have trimmed it by 30 minutes, make it more like a 2-hour movie, but the storytelling is very great. The science, I was kind of curious to see if you had any doubts on certain scientific aspect of it, but it was a great story.
My guess is that I will, but I've not yet seen it.
Are you able to turn your brain off?
Yeah, totally. You know, here's my general way of being in a theater. If the filmmaker and the story is consistent, even if the rules by which they're operating are nonsense, I'll go with them because I'm willing to bend everything just to have a really good story. What really bothers me, and I think many other people too, is if at the last minute they change their own rules in order that whatever narrative climax, you know, can make sense. I remember years ago, I was flown out to be an advisor on, it was the film Deja Vu. I don't know if you saw that. Denzel Washington. It was sort of a time warp kind of thing. And I loved working with those guys. But there was one moment that was really curious. So, you know, I'm in the studio executive's office. There's like 10 people around the table, the writer, the producer, all this. And I'm telling them all about how you get a time warp. And I'm doing special relativity. I'm doing some general relativity, you know, not detailed mathematics, but enough that they were getting the gist of it. So it took a number of hours because they really wanted to dig in and sort of know, at least qualitatively, how this stuff works. And at the very end of this multi-hour discussion, one of the writers chimes in and says, but couldn't we still have this sphere that comes in from the other dimension? And I was like, look, you can do whatever you want. But if you're going to break the rules, at least know the rules that you're breaking and just try to keep it semi-consistent or as consistent as it can be. And I remember seeing the film and I thought it was pretty good. You know, it was like some weird 4-minute time lapse between a time window that they had or something like that. I think they stayed reasonably close to consistency, although I can't swear to it. But yeah, you know, I think that's what really matters in the end.
In general, if they're consistent, like you said, into those rules that they break, sometimes it's just, there was no reason not to make it correct into the movie that would have kind of make it more consistent or more believable.
I agree. That's a drag when you see that. Yeah.
Because then it makes you just kind of look at everything from a cheap perspective.
So that's laziness, you know, I think, not really delving in, but yeah, for sure.
And then diving into anything that is multi-universe and timeline like Marvel did, which they just got lost into trying to figure out how to connect all these different narratives. You should have kind of just left away. I mean, do you believe that at one point traveling in time is something feasible, or?
It depends on which variety, going to the future or going to the past. So going to the future, and by that I don't mean like we all are aging, so we're going to the future. Saying if you want to leapfrog to see what Earth would be like 1,000,000 years from now, Einstein actually laid out an algorithm, a strategy that's completely uncontroversial for doing that. Actually, 2 strategies. He said, look, if you go out in a rocket ship, deep space, go really near the speed of light. That's hard to do, but let's put technology to the side. Go really near the speed of light, turn around and come back. If you go out 6 months and come back 6 months, of course, you're 1 year older when you get off the ship. But your clock and Earth's clock will have been ticking off time differently, he showed, and all the experiments established. And if you go fast enough, when you come back, Earth's clocks will have ticked off 1,000,000 years, even though your clock has only ticked off once. So when you step out of the ship, you will have time traveled into Earth's future and the future of the environment. That is unquestionably what would happen. Another strategy is go hang out near the edge of a black hole. Near the edge of a black hole, time is slowed because gravity pulls on it, slowing its passage. And we saw this like in Interstellar. Right. So Matthew McConaughey, Anne Hathaway, I believe those are the actors, you know, they go near a black hole and they're on the planet, Gargantua or something like that. I don't remember the names, but they're there for, I don't know, an hour or two. They come back to the mothership and their companion, their crew member, is 23 years older, even though they were only gone for a few hours, because that clock on the ship was ticking off time much faster than the clock near the black hole. So these are versions of time travel, but they're all pushing you into the future. The unknown question is, what if you want to go the other direction? What if you want to go into the past? And most physicists would say it's either ruled out or unlikely. The fact of the matter is it's not really ruled out. There's a lot of circumstantial evidence that makes it hard to believe that we could travel to the past. But people have even suggested approaches involving things like wormholes, these hypothetical tunnels through the fabric of space. And again, if you have a wormhole, it's kind of a shortcut from here to here, shortcut in space. But if you take one opening of the wormhole and let it hang out near the edge of a black hole, it ages at a different rate than the other opening. Now you've got a shortcut not just through space, but you have a shortcut through time. And so in principle, if you had a wormhole, no one has one, we've never seen one, there's no evidence that they could exist, but the mathematics allows them possibly to be out there. If you had a wormhole and you played this game of towing one end near the edge of a black hole, then yeah, you could get a shortcut not just through space, but a shortcut through time. And it could go either direction.
When you were talking about jumping forward, it's not like you're jumping on the timeline. It's you're experiencing time differently. So then when you come back, you've processed time indifferently, but you could not change that and then go and move back. Your experience of it is different. When we talk about going backward, is about things that have happened, and now it would demand that you undo these things, and this is the problem.
I would say 2 quick things on that. The time travel to the future, I understand your intuition, which is to sort of say, well, that's not really time travel because it's really just you're experiencing time difference. But I would encourage you and others to interrogate that critique, because what we really mean by time travel is just that we can experience the future. And this is a approach for doing that. I mean, again, if I can be on Earth in the year 1 million, I've time traveled. Now, you might say, isn't it sort of like cryogenic suspension? You kind of like went to sleep for like 1 million years and you're just woken up. Well, not really, because in my brain, I was experiencing reality on that spaceship. Reality was as it always is. And it's just that when I jumped out of the ship, when I landed back on Earth, things were far into the future. That to me is time travel. But on the second point, you're right. I mean, one of the real challenges, if you can travel to the past, are these paradoxes that we've seen Back to the Future, right? Like Marty McFly goes into the past and prevents momentarily his parents from meeting. How would he ever be there if his parents never met? And so if you recall, he's got a photograph. He begins to kind of fade in the photograph. What do we do? Because that would be paradoxical, because if he was never born, how is he there to keep his parents apart in the first place? So you're like, oh my God, the world's not making sense any longer. Now, there are potential solutions to that paradox. One solution is, if you could travel to the past, maybe you simply can't change things. Or you can't change the things that really matter. Maybe the universe locks those events in place, and no matter how hard you try, you don't have the freedom of will that you thought you had to be able to change things. That's one possibility. The other possibility is, back to this idea of multiple universes, maybe when you travel to the past, you always wind up in a parallel universe. So you can't ever affect the things that allowed you to exist. Maybe Marty McFly is preventing his parents from meeting in a different universe. So in that universe, maybe he is never born, but his origin is not confusing. He was born in this universe where his parents did meet. So it's not to say that these are the solution, but it's just to say that you can't use these paradoxes yet to claim that travel to the past is impossible. Because there are, in principle, solutions to these paradoxes.
Do you think this is just an unended question, that it would always exist because there's no way to not prove it? Like if there's God or no God, well, not too sure they will ever be answered, because even if you have an answer that proves you're wrong, you still have room to question.
Yeah, you're right. I mean, every proof relies on assumptions. And every list of assumptions can be questioned because maybe the assumption's not correct. And so, and moreover, it's very hard to prove negatives, right? To prove that something can happen. It's much easier to prove that something can happen. You just do it. You find a way of doing it, do it. And that's unquestionable at that point. So, physicists are very clever folks. And so I never will put it past them to either prove something correct or not correct, depending on how the universe, its disposition on, in this case, time travel to the past might be. So maybe 100 years from now or 5 years from now, some clever person will come along and say, aha, here's how you do it. And maybe we carry it out. Or some clever person comes along and says, look, if you believe in Einstein's ideas and quantum mechanics and the things that we've really established experimentally, then I've got a proof that time travel to the past is impossible. That would be interesting, because those assumptions are so rock solid that we would take that proof pretty seriously.
So what are the check boxes that you're looking to answer in this time that you have been given? Are there like these big questions that you feel that are just around the corner and are going to come answered in the next 50 years?
I mean, there's some pretty foundational questions that have certainly driven me and driven my colleagues as well. You would really like to understand what time actually is, what space actually is. We just started this conversation with the possibility that space might not be as fundamental as we thought. There might be more basic ingredients. Answering a question like that is something that is driving a lot of us to take the baby steps in search of insight into questions like that. I mean, when I began graduate school back in the 1980s, it was a fascination, as I said, with extra dimensions of space. Could they be real? What might they be like? That then transformed into a real deep interest in cosmology. trying to understand how space expands over time and try to understand the intricacies of what that means and what powers that expansion. And that transitioned into yet other fascinations with the possibility, for instance, that maybe quantum physics is vital to how space changes over time. And maybe there's an imprint of quantum physics that we can see through detailed observations. And that has been borne fruit in the microwave background radiation that perhaps you've heard of, is tiny temperature differences that we've been able to measure in the deep night sky that we believe have their origin in quantum fluctuations that we discussed before. So in some sense, you've got quantum physics written large across the expanse of space itself. I mean, these are fantastically deep insights, but sort of the big question of all for someone like me is there a single theory that embraces all of these wondrous ideas? Is there the unified theory that Einstein was looking for? And from my early days as a graduate student, string theory was a proposal for this unified theory. It still is on the table, very much so, but we've not been able to test it. We've not been able to determine if it is relevant to reality that we live in. And that's been the big stumbling block. So in 50 years, might we have a test of string theory? It's possible. And, if it's proved wrong, I'd be thrilled. And sometimes people are quizzical when I say that. You've been working on it your whole life. Why would you be thrilled? To be thrilled because I don't care about any particular theory. I care about truth. And so if you can prove that an area that we've long been working on is not right, fantastic. We wipe it out. We put it to the side. We put our attention on other things that might be true. On the other hand, maybe there'll be evidence for string theory. And how thrilling would that be, that with these little creatures walking around planet Earth, barely coming of age in the Milky Way galaxy, to have stumbled upon the unified theory? Wow, that would be thrilling. So however it turns out, it's exciting.
If you ask me about the string, I do believe it exists. I did share with you the experience that I had on ayahuasca where I looked up and I just saw strings everywhere. I saw how pushing something here rippled in different ways, and the understanding that everything was connected in ways that we didn't know. I mean, that was an experience, whether that's how the universe is. It's a different.
And look, I value hearing of those experiences, and maybe one day I'll be brave enough to actually have one of those experiences. But my suspicion is that they tell us much more about ourselves than they do about an objective external reality. That doesn't denigrate it, but rather it's an inner focus as opposed to an outer focus, my guess.
It's a conversation that happens often in that world, that if it was some kind of reality, then it would be seen over and over in the same way by everyone, independently who you are, how you do it. Once you cross into that realm, this is the experience. If you go to a different country, doesn't matter who you are, that country, that place is the same for everyone. But when you do those kinds of experiences, you have as many versions of many people who have experienced it. So there's so much of it that is personal.
But Daniel, I'd also say along those lines, and tell me if you disagree, even if you and a million other people who were on ayahuasca had the same vision of some kind of strain connecting rippling, my suspicion would still be that it's emerging from a commonality of human physiology and the way the brain operates and how these chemicals are manipulating the normal functioning of the brain. I would still view it as something insightful about in here as opposed to necessarily something telling us about out there.
No, absolutely. If you do want to try it, I can share some.
Well, I have some friends. We did a program at World Science Festival on psychedelics, and one of the producers of that program runs in Austin, Texas, a medical facility that does microdosing for various reasons. And generously, wonderfully, she's invited me down. I've never quite done it. I'm thinking of, that seems to me a nice baby step, where there's actual medical people holding your hand, so you're not freaking out as much maybe. And, I think that probably would be the way for me to do it at some point.
I would always say that it's worth experiencing it, because I think that there are things in life could make the same argument for people that express that into religion. There are things that are just not necessarily easy to quantify or to explain, but have transcendence to the experience. Definitely before your death, this need to feel that you're connected to something bigger. Maybe you will find that answer for the string theory if you decide to do a little trip. Brian, do you think that the human species has a place in beyond Earth in space?
I do. Yeah, I think our fundamental nature is one of exploration. It's one of the things I think that drives us most powerfully and we hold dear. We extol those who had the bravery in the early days of our species to go out and explore this planet, and rightfully so, although what they did was not always beneficial for those who were inhabiting other realms. So if we're going to do this, we need to do it, I think, with a mindset that is very much one that, I'm not going to say Star Trek always had it right, but, you don't want to go out there and start messing out whatever else might be there. Now, look, we don't know if there are any other civilizations out there. It's intuition, of course, tells us if you have that much space, there's got to be other life out there. But the one thing I would say there is that, I think, is a convincing and compelling argument, because all the ingredients, amino acids and, the nucleotides that we are aware of as being essential to life, they're relatively commonplace. But, on planet Earth, it was single-celled organisms for billions of years. And it was, chance events, we believe, that allowed those single-celled organisms to go the next step and get multicellular, and then go the next step and ultimately get to intelligent beings. So there may be a lot of life in the universe, but it may not be the kind of life that we can actually have a conversation with. And so I think, God willing, or sensibly navigating the challenges that we have, we will leave this planet. And I think that's a thrilling possibility.
And I believe the driving force of life is to connect on the planet. So beyond the planet, it's the same thing. And the scale of the universe is precisely so that somewhere, somehow, the events will make a species or an organism that will be able to continue that connection. And here we are now, the human species. Otherwise, it would be such a waste of effort, of energy to create complex organisms only to disappear when the sun goes away. And then, it would just be sad. So now that we have one species that has the capacity to take that life beyond the planet, not only do we have a place, but we have a responsibility to do it. So continuing the story, the nature story, the life story, this is what it is. And if you look at our evolution from a single-cell organism, which idled for billions of years, and when it jumped to multi-cell, it was a huge jump, but it created an entire new field of evolution, and life exploded. And now we're about to go from single planet to multiplanetary, which will create an entire new field of opportunities and possibilities. So
the one thing I would say, though, for someone like me who is comfortable and almost forced by the work I do to think about timescales that are much, much larger than the timescales relevant to a human being. And when we talk about centuries or millennia, the timescales that sometimes we deal with, you've got centuries or millennia in the exponent, and it's an exponent of, so it's huge. And one of the curious things when you talk about SAD is the following. Very mild assumptions allow you to establish that if you wait long enough, all life in the universe will be gone. All intelligence in the universe will be gone. And now, granted, the timescales on human sizes and scales are absolutely enormous, like 10 to the 50 years or 10 to the 100 years from now. But from a cosmological perspective, it's a blink of an eye. And so in some sense, in a blink of an eye, all life will likely be gone, and the cosmos will carry on for a near eternity after that in a lifeless state. And yeah, that really can grab you if you allow that to sink in fully, that everything we care about, everything we love, everything that we talk about as intrinsic to who we are as a species or or what life means to the cosmos, the ability of the cosmos to reflect on itself through living systems, that's probably a blink of an eye. And the rest of eternity doesn't have that.
Do you tend to believe that the universe, the age of the universe, is not linear, where there's a beginning or an end, is more of a cycle where it dies and then it reborns itself? So the Big Bang was not necessarily just the beginning of everything. It was just the restarted of what had finished before that.
Well, I like those theories. There are a handful. And one in particular by a colleague of mine at Princeton named Paul Steinhardt and his collaborators is the most, I think, well-developed version of a kind of cyclic cosmology, a cyclic universe. I'm not convinced of those theories yet. I perhaps am still old-fashioned in my thinking where, yeah, I do see the Big Bang as the beginning of at least our realm. And our realm will have a linear progression, and the universe will continue to expand. The universe will continue to get colder over time. And when I talk about life being extinguished, I'm not talking about life on planet Earth. I'm talking about life anywhere in that realm. And so, yes, it's a more palatable idea to envision that that's just one cycle. And then there'll be subsequent cycles where there'll be another Big Bang-like event and life has the chance to emerge a second time and a third time and so forth. I like that idea. I'm not driven to give it the same weight at the moment as I do in the other version, where in our universe, there's a beginning, there's a middle, and there's an end in the sense that there's an end to life. And then the comings and goings continue, but they're not noticed by anybody.
When I said the nature of Earth is nothing different than the nature of the universe, is for those reasons where in nature, nothing is eternal, but everything is always recycled. And you need those disruptions to create life or to create evolution. And one of the things that I discussed about why is it that we have life on Earth is not necessarily because we have the ingredients for life, is because these ingredients have been constantly being mixed over and over by these three different rhythms, the seasons, the days, and then the years. And all those tensions or these rhythms are constantly just mixing your dough of bread, and where ultimately now that creates the opportunity for something to happen. Because otherwise, if it was just the ingredients, you could have the ingredients on a table and you could look at them for millions and billions and eons of years and nothing would happen. And it's that tension that nature is always seeking because it wants evolution and wants adaptation. But the sense of eternity, nature doesn't want that at all. It wants a capacity to renew itself or to create space for something else. And for me, the universe is just the same thing, but on a different scale.
The only thing I would say on that is the caution that I don't think the universe wants anything. The whole conception of want is a very human idea. So, and sometimes it's what you or what we want is a universe that sort of has this capacity to recycle and regenerate and rebirth. The universe doesn't really care what we want. Now, it's natural to, again, to extrapolate from what we're familiar with on Earth, which are the seasons and there are these rejuvenations and this mixing together that you beautifully describe. But, we also know that, the sun will burn out and it will likely swell and swallow up the Earth. And if it doesn't swallow up the Earth, then the Earth will spiral into the dead sun, losing energy from gravitational radiation. If you wait 100 billion years, that's what will happen to the Earth. So cycles can come to an end. And so it's dangerous to extrapolate that because we see cycles, the universe is cyclic in its fundamental nature and will always regenerate. It could be that the universe yawns when we humans say we want it to be that way, and it will just have an eternal stretch with not much happening. That's a possible outcome as well.
The want is always, yes, it's a point of discussion because it's hard to express it. I mean, if you look at life, the force of life to move forward without wanting to give it some type of personality, it's always challenging to find the right words. But there are theories that the universe might just follow more the rules of some fundamental principles like gravity, where it's a force, there's nothing around it, it just continues expanding.
In fact, my most recent book is called Until the End of Time. And it really tries to lay out the most trustworthy principles that guide how the universe does unfold. And I wind up focusing upon the idea of evolution that has come up in our conversation, which is how complex structures can form without a guiding intelligence. But the other foundational principle is the second law of thermodynamics. In fact, Albert Einstein described the second law of thermodynamics as the only law that he was confident would never change. He wasn't even certain about his own description of gravity. And in the second law of thermodynamics, there is this drive toward greater entropy, greater disorder. And so if you wait long enough, disorder ultimately rules. It ultimately wins. And disorder means that things wither. They fall apart. And they don't necessarily regenerate in the most cyclic manner that you would describe. It's not that they can't regenerate, and maybe they do regenerate, but the timescales for that to happen may be unfathomably long, even on the unfathomable timescales that I was already introducing, like 10 to the 50 or 10 to the 100 years. It's hard to think in those terms. And so maybe there's some kind of rejuvenation on even more fantastically long scales. But, on 10 to the 100 years, we're now 10 to the 10 years from the Big Bang. 10 to the 100 that makes from the Big Bang till today. If I called it a blink of an eye on those scales, I would be overestimating how long it is. It's a fraction of a blink of an eye. On those scales, it may be that life is just there for a moment. There's this wonderful quote, I think comes from Nabokov, that life exists between two eternities of darkness, a brief crack of light. And that really may be what we are, just this brief crack of light between these two expanses that are lifeless, before us and after us.
We'll see. It's just that every time that we think the end of something is there because we don't know about it or because we can't really imagine it, then our default place to go back to is say, well, it's the end of it. We even thought that black holes was the end of it. And then, Hawking's radiation, we know that no, whatever goes in actually has to go somewhere, and now we can see it. So the consistency that we can go back to is that every time that we think it's the end, it's not the end, it's something else. As we scale to the universe, there's nothing that for me proves that this would be different. Quick question, Brian. On the board behind you, is that something that's always there, or it changes every day depending on what you're working on?
Well, this has unfortunately been here for a while because I've been working more on paper and pens and iPad. But this is actually the mathematics describing extra dimensions that have a bizarre quality that's akin to the Mobius strip. The Mobius strip that, you go around it and there's no inside or outside because it twists on it. So we were contemplating a universe where the extra dimensions have that kind of feature, and some very interesting qualities emerge.
Even to people who don't follow mathematics, everyone who has seen Infinity War with Marvel, that's what Tony Stark is able to answer going back to the past with the Mobius strip. And
great. I've not seen it, so yes.
Brian, what would be your 3 words of wisdom?
Humility is a big one. Gratitude, I think, is a powerful one. And patience. To me, those are the hallmarks of an explorer. Not necessarily only the explorers who actually go out in the ships, but, in my work, as I try to explore, I'm constantly grateful that the universe is as interesting as it is. I know that I need to have patience in trying to seek answers, so these are just part of the qualities that I think make life worth living.
Do you look back at some of the knowledge of the Chinese society, 1,000 years ago, or the Aztecs, or some former societies that had knowledge of the sky that is kind of baffling because they didn't have the tools? They had the time, but do you find yourself sometime looking at it and just go, my God, they didn't do that?
Yeah, and I think that's where the third word, humility, comes in. Consider ourselves to be relatively advanced technological scientific society, but I think, we're all struggling at the beginning. I think this journey to deep knowledge is one that's going to carry on for a very long time. And I think it is remarkable that some ancient societies and civilizations, they had the same drive that we do to try to figure stuff out. And through patience and careful observation, they made some headway in understanding the patterns of reality. In the end, that's what we are. We are pattern-seeking entities that try to use an understanding of pattern to gain explanatory understanding of the external world. And we don't have hegemony over that. And many earlier civilizations have done a wonderful job at trying to begin to distill those patterns.
Dealing with that scale of change and impact and timeline, do you worry about the minute little day-to-day or even, what we're going through right now as a society? Or are you the one in a conversation at the table who's just going to go, but you don't understand. If you step very far back, this is nothing.
I kind of do both. I mean, I'd love to sit here and say that I am sort of the anchor of stability and calm in a torrential world. And as my wife and my kids will tell you, that's sometimes the case, but by no means is it always the case. So I can get caught up in the detailed minutia of what happens to us as individuals or as a society as much as anybody else. But what I will say is I always have in parallel the cosmic conversation, the cosmic perspective is there. It may not be dominant. It may not be able to assuage my own anxiety at a given moment, but ultimately I can fall back to that perspective. And it is one, I think, that can be deeply comforting. It can be scary too. I mean, when you look at, as we've been talking about, life, entirety of life is a blink of an eye, not just a human life, but the concept of life as being a blink of an eye. That can be very scary. But at the same time, it also shows you, or shows is the wrong word, it also focuses your attention on the extraordinary wonder of this moment. That this moment is so rare in the cosmological timeline, that there can be living systems that can think and feel and love and explore and do the other awful things that we do to each other as well, unfortunately. But there's a deep sense of appreciation that we are here for this brief moment that didn't have to exist. And that to me can be really inspiring. And so, in the tumult of it all, I can get pulled into it, but I do have this alternative framework of understanding that's always there.
Absolutely agree on that. You might have no meaning in the big picture, but you have all the meaning in that present moment.
Yes, exactly.
And you create that meaning with these relationships that you do and with what you create. And that is what is important in the big picture of things.
100%.
Yeah. And so, Brian, it's been wonderful. I've been wanting to have this conversation with you. I always love to go down these rabbit holes, combination between philosophy and life and the rules of the cosmos and science fiction and everything. And we will be back together in 1 year-ish up in the Arctic.
Yes, looking forward to it.
Just for the audience, the World Science Festival, what's happening with that this year?
Well, we have ongoing conversations, sort of like the one that we just had, which we try to post roughly every other week. And then we have a big live show that we're planning in the fall in New York City. And we're still working out the details of that, but people should just sign up to worldsciencefestival.com and we'll alert them of what's going on.
Excellent. Looking forward. Well, see you. We'll be in New York in April and then obviously for fall. But big hugs to you and the family.
Thank you so much. Good talking to you.
Thank you, Brian.